Okay, little chapter 6 review, lean systems. It's important to know what's a lean system. So basically it's what it says here. So you want to maximize your value add, and how you do that is you remove waste and delays from processes. These are the 8 types of waste that you can have. You can have overproduction. This comes when you have inventories in the wrong place. Inappropriate processing. You may process something when it shouldn't be. Waiting. This would come from chapter 5 with constraints, when you have your bottleneck process, in particular waiting. Transportation. This can come internally or externally, but internally maybe moving things around in a factory too much. Motion. This can be worker motion, wasted motion, product motion, which is kind of tied into transportation, and the motion adds up to time. Inventory, carrying it in the wrong place, carrying it when you don't need it. Defects. So the more defects you have, of course, the slower a system is going to be. And underutilization of employees. Just to tie back to constraints, sometimes that's just necessary. I know, for instance, in construction, a company might have an employee that they value and want to keep that employee on, and purposely underutilize them. So when they're needed, they're utilized heavily, but they want to pay them when they're, even when they're not being used, because they need that person on staff. So is there a way to find work for that person to do? Can you train them in another area to get more work out of them? One of the ways to do that, to eliminate that waste, is to do value stream mapping, so you can see where value is added on to a product as it goes through its processes that assemble, manufacture, or provide a service. And this is how you do that, is to figure out where you are, figure out where you need to be, implement it, and then go back to a current, now this is what we have, and where's our next optimization going to come. The value stream mapping uses a set of common icons so that everybody knows what it is. There's nothing wrong with value stream mapping, but I know what I use for processes is a business process modeling notation to figure out the same kind of thing, where to optimize. It's all about documenting. Just as the constraints uses a precedence map, this is what you're trying to do here, except you're taking it from a holistic, this is the whole state of the system. There are a number of metrics that you need when you're doing the value stream mapping. The reason for this is this helps you to identify the bottleneck, but also shows you if the bottleneck is underutilized or overutilized or inappropriately utilized. In the case of a bottleneck, it would usually be underutilized, which means somewhere else in the processes that are available, something isn't being done correctly. So I just mentioned Kanban, which is your card system that is again coming from manufacturing more so than service, and it's the record of a card that refers to production in a factory. Materials flow usually, and the Kanban has a bunch of rules, which really, these are the general operating rules, but they're very important to know. And because we're dealing with a container system, the card goes with the container on the outside, on the inside. Some kind of container can be as small as a letterbox, shoebox, or it can be as large as a container that goes on the back of a truck. But what's important to know is every container must have a card, so there must be a card for a container. A container cannot be moved around without having a card. Okay, so every container must have a card. In keeping with lean systems, the assembly is always going to pull from fabrication. So that means raw materials come in, a sub-assembly or a piece gets fabricated from the raw materials, and then for assembly it is pulled. I already mentioned this, but containers cannot be moved without a Kanban, so no container can move without a card. And in keeping with lean systems, containers should always contain the same number of parts. And number 5, only good parts are passed along. So this is the inbuilt quality control. And then production should not exceed authorization. So when because we're dealing with a pull system, production should not be in excess of what has been requested.